Find the area of the surface generated by revolving the curve y equals negative x cubed over 9 between negative 2 and 0. Okay. If y equals x cubed looks like this, then negative x cubed will be in this orientation. Okay. And so we want negative x cubed over 9. It's just some alteration of how steep it is. And so we're looking at something basically, we don't have to actually get a visual here, but it's going to say something like this. Between 0 and, I don't know, let's just mark off here negative 2. I'm going to take and revolve this about the x-axis and get some sort of a shape. I like the surface area of that shape. So we take the x-axis as our axis of rotation that we're going to revolve about. And so we set this up to be then surface area about the x-axis. The formula is 2 pi times the integral of y ds, where ds could be in x or in y, and that y can stay as a y, or it can flip and go and replace it with the function of x. Let's try this as an x integral. Well, let's try it. Maybe something goes wrong. I don't know. Let's see. Let's try it as an x integral. Okay. So in x we have, I'm sorry. Yeah, if it's in x, then this thing is it's a dx integral. If it's in y, it's a dy integral. Okay. If you're a dx integral, then this y is not happy as a y. You're going to have to change the y with f of x. Take that instead. If it's a dy integral, then you leave it as a y. Okay, great. Oops. Well, it doesn't look too good. Leave it as y. All right, great. So let's say we're going to try this f of x approach. So 2 pi, the integral. We'll figure out the limits in x in a second. And we put the function f of x. And then ds is the part of arc length. It's 1 plus y prime quantity squared dx. So if y is negative x cubed over 9, then y prime is negative 3x squared over 9, or negative x squared over 3. We square that, and we get x to the 4th over 9. We add 1 to that, and we get 9 plus x 4th all over 9. And so we take the square root of that. Okay, which is going to be the root of the numerator divided by the root of the denominator. And so all in all, here's what we're looking at. What about our limits of integration? What does x go from? Well, I kind of give it to you in the problem here, but yeah. X is negative 2, and then x is 0. All right, good. So this is going to be a 3. And we have this 9 and this 3. Okay, so that's going to come out. We'll have 2 pi over 27. Um, let's take the negative out too, and have x cubed times the square root of 9 plus x fourth. Basically, works out well. Why does that work out well? There's certain things you should look for when you're trying to integrate, and when you have an inside function, it's a polynomial, but when it's two terms like this, a constant and the exponential, and a power term, and the power term has one power less than, one power more than what's on the outside power, that's a quick u substitution. Let u be the entire 9 plus x to the fourth. Du is going to be 4x cubed dx. We need to get rid of x cubed dx, so we divide by 4. And we get that 1/4 of du is going to take the place of x cubed dx. Okay, and so we'd have 1/4 u to the half du that we'd integrate. That would be u to the 3/2 times 2/3, and there's also that 1/4, and this 2 can cancel, and we'll call it 1/6. Sorry about the scratch work overtaking each other. U to the 3/2. So that's our antiderivative. We have the negative 2 pi over 27 times the 1/6 of 9 plus x to the fourth raised to the 3/2 power, evaluated from negative 2 up to 0. Pull the 1/6 out. Almost done. We put the 0 in, and we get 9 to the 3/2. We put the negative 2 in, 2 to the fourth. Negative 2 to the fourth would be the same as 2 to the fourth, which is 16. So 25 to the 3/2. 9 plus 16 is 25. And then over here, let's call it this 6 could turn, this 2 could turn the 6 into a 3. And let's call it negative pi over 81. Okay. 9 to the 3/2, 9 being 3 squared, is 3 cubed. The 2's cancel, and you get 27. 25 to the 3/2 with 5 squared being 25. 2's cancel, and it's 125. It's a 5 cubed, which is 125. So we'll have negative pi over 81 times 27 minus 125. It's negative 98. So pi times 98 over 81. Anything we can do with those? I don't think they share anything in common, 98 and 81. Because 98 is 49 times 2. So 7s and 2s are in its prime factorization. And all 3s are in this guy's prime factorization. So that will be our answer then. Side work over here. Sorry. We get 98 pi over 81. If I didn't make any mistakes. Which is, highly likely, unfortunately. But we get the gist of it. And hopefully that's enough to explain the problem to you. Surface area revolution question with a simple curve, negative x cubed over 9, but it caused all this work. We get an answer of 98 pi over 81.